Evaluating models, accuracy, precision, recall, and cross-validation. Welcome back to Python for AI and Machine Learning. I am Dr. Azad Rasul, and in this lecture, we will diving into evaluating machine learning models using metrics like accuracy, precision, recall, and cross-validation. Today, we will train the random forest model, calculate accuracy, precision, and recall from metrics, and use cross-validation to check its stability. By the end, you'll be ready to evaluate models for coming projects. Let's get started. Setting up the model and dataset. Let's set up our random forest model on the crop health.csv dataset. Just like in the previous lecture, this dataset has 1000 rows with NDVI, soil moisture, and health column. Here's the code. Import libraries, load data and clean dataset, split feature and labels, split into train and test sets using 20% and random state 42. Train a random forest model, random forest classifier, then predict on test set. We change runtime, upload our crop health data, let's run the script. This code loads CSV file, cleans missing values and NDVI outliers, and convert text labels to numbers. The train test split function splits the 1000 rows into 800 training and 200 testing samples with a random state 42, ensuring reproducibility. The random forest classifier, a collection of decision trees, learns patterns from NDVI and soil moisture to predict crop health. The yPred variable stores predictions for the 200 test samples. Run this code to prepare for evaluation. Calculating accuracy, precision, and recall. Now let's calculate accuracy, precision, and recall to evaluate our model using the confusion matrix. Here is the code. From scikit-learn.metrics, import confusion matrix, accuracy score, precision score, and recall score functions. Generate confusion matrix, CM equal confusion matrix using ytest and ypred. Calculate matrix accuracy equal accuracy score using ytest and ypred, while precision equal precision score using ytest and ypred, and recall equal recall score function using ytest and ypred. Then print output values. The confusion matrix function compares actual labels ytest to predictions ypred, giving 138,2 and 4,56. Accuracy 4.97 and precision 4.97, while recall equal 4.93. We have true negative of 138, false positive just 2, false negatives 4 and 56 true positives. The accuracy means 97 of predictions are correct, while precision equal 0.97, 97 of crops predict as healthy, and 97% are actually healthy. Recall TP divided by TP plus Fn equal 0.93. The model identifies 93% of all healthy crops. The accuracy score, precision score, and recall score functions compute these automatically. High precision is great for farmers to trust healthy predictions, but the lower recall means missing for healthy crops, which we will address it later. Using cross-validation for a post-evaluation. To ensure our model isn't just lucky on one test set, let's use cross-validation to test it across multiple data splits. Cross-validation splits the data into folds, trains on some, and tests on others, averaging the results. Here's the code for 5-fold cross-validation. CV equal 5, model X and Y, scoring accuracy. Then print cross-validation accuracy score, mean CV accuracy, and standard deviation. Cross-validation accuracy scores 0.68, 0.85, 1, 1, and 0.79. Mean CV accuracy 0.86 and standard deviation 0.12. The cross-val score function splits the 1000 raw dataset into 5 folders, training on 4 folders, which means 800 rows, and testing on 1 fold, which means 200 rows each time. It computes accuracy for each fold, returning an array like 0.68, 0.85, and so on. Our output shows a mean accuracy of 0.86 and standard deviation of 0.12. The mean of 0.86 is lower than our test accuracy of 0.97, suggesting the model performs worse on different data splits. The high standard deviation of 0.12 indicates inconsistent performance. Scores range from 0.68 to 1 are widespread. This variability, combined with the IUC of 1 from the previous lecture, confirms overfitting. The model memorizes the training data but struggles on new folders. Run this code to check your model's stability. A mean below 0.90 and a high standard deviation signal the need for model adjustments, which we will cover next. Interpreting metrics and improving the model. Let's interpret our results. The confusion matrix 138,2 and 4,56 shows 97% accuracy, but the 4 false negatives, recall equal 0.93, means we are missing some healthy crops critical for farming applications. The cross-validation scores with a mean of 0.86 and standard deviation of 0.12 confirm overfitting as the model is performance varies widely and is lower than the 97% test accuracy and AUC of 1. To improve the model, first simplify the model. Use random forest classifier, max depth, for example, equal 3, number estimates equal 50 to limit tree depth and reduce complexity, preventing overfitting. Next, added features include more crop data like temperature or rainfall to make the task more realistic and reduce reliance on NDVI and soil moisture. Next point, adjust data split. Set test size equal 0.3 in training test split for a larger test set, 300 rows, making evaluation tougher. Final point, tune hyperparameters. Try cross-val score with a score-equal recall to prioritize catching healthy crops. These metrics are vital for models of crop health predictor, ensuring reliable predictions for farmers. Experiment by applying these changes and comparing your cross-validation scores. In summary, we have learned to evaluate ML models with accuracy, precision, recall, and cross-validation. Using our crop health model, 97% accuracy and 0.93 recall. Complete the coding exercise to compute these metrics and take the quiz to test your skills. Share your cross-validation results in the Q&A forum. I'd love to see them. Let's keep mastering AI and ML.